Hello, Algebra 2 students, and welcome to Mr. Paul's videos. I'm sure you're all thrilled, but hey, you ever need some help? These are good places to go. So, Chapter A sounds kind of weird, like why not Chapter 1? So a couple years back, we added some ACT standards that we weren't bothering with before, but now that the ACT test is a little more important to you, we're going to go back and we're going to hit some review of some Algebra 1 stuff. So, let's start off with some steps for solving equations, which I hope by now you guys know. Let's go ahead and put them out here anyway. So first thing you always want to do, really, any kind of math problem, is simplify. Okay, now what that means, though, is there something on a given side that you can go ahead and do? So if you look at the first problem, number 1 right here, 3x plus 7, I can't actually add the 3x and the 7 together, so I'm going to have to move stuff from side to side. So there's no simplifying that goes on in that one to start. But if you look at number 2, over on the right side, there's a -1 and -9. Well, we're going to be able to combine those. There's a 4x and plus x. We're going to be able to combine those. So that's what we're talking about when we say simplify. So step 2, we're always to attempt, you don't have to do this second, it's just a good idea, to get the variable, I'm going to abbreviate, on one side. So again, first problem, we're not going to have to bother with that. There's only one x, he's on the left side. Same thing with this second problem. But if you get down to that third problem, there's an x on both sides. So that's what we're talking about there. Step 3 is to always take care of or move anything involving add and subtract. And then step 4, move or get rid of, to both sides of the equation, any multiplies or divides. And then step 5 really is optional, but a good idea if you have time. And if you're one of those extra efficient people, hey, check it if humanly possible. All right, so off we go. Number 1. This should be a review, but let's check it out anyway. I like seeing the work. After a while, we get good at this. You guys prove to me you can do this. Without showing the little -7, we'll let it slide. But for now, opposite of +7, -7, that's how I'm going to move them. 7s are gone. I do know some of you like putting a line down the middle like that, and I'll go ahead for this problem, but I'm not going to after this. So -20 and -7 will make -27. It's like calling Algebra 2 big boy and big girl math. If you want to put the line, that's fine. So how do we get rid of a 3 when it's 3 times x? We divide, we go opposite. Divide by 3 on both sides, we got -9. So again, I would hope that's kind of second nature for you. Number 2, so this is something people do tend to forget, I will admit that. But that's what we're talking about for step 1, simplify. So this guy and this guy, they're on the same side. And if I just had written, hey, -1 and -9 on the board and asked you to add them, pretty confident you would have told me it was -10. So we don't want to move anything yet since these guys are on the same side. I got 4 of something, I got 1 of something. Total 5. And then we're going to start moving stuff because I eventually got to get the x by itself. Add 10 to both sides. By the way, you will notice my writing will get nasty after a while. That's what happens when you get old. You get arthritic and your hands hurt. Hey, 5x, it's 5 times x. Divide to get rid of it. And I got a 4. So again, checking, entirely up to you, but never a bad idea. If I were to take the 4, plop it back in for all the x's in the original problem, I'm going to tell you right now it's going to come out to equal 10. Alrighty, a little bit tougher down here. We've got some more stuff going on. I hope we're familiar with the distributive property. That's part of simplifying. In other words, stuff you can do on one side of the equation before you worry about moving anything. So just multiply those both by 3. Now you get your choice here. I mean, we could move the 15, we could move the 22, but usually you want to get the x on the same side first. You could move the 4x if you want, but I'm going to tell you what, if I want to get rid of negative signs, which is always a good idea, I'm going to go ahead and choose to move the 6x, because if I move the 6x, that minus sign's gone, one less negative sign to worry about. Well, 4x and 6x total of 10x. plus 22. Doesn't matter which side the x is on. Some people like it on the left side. Doesn't really bother me either way. So 22. So the next step is to always do add, subtract, save the division for last. So if I subtract those guys, calculator certainly permissible here. I get a -7, 10x, and divide by 10. Now nowhere does it say in math that answers have to come out even. So I get a fraction, -7 divided by 10. If you want to pick up a calculator and punch that in there, it's going to tell you 0.7. But I'm going to say, hey, as long as fractions are reduced, 7/10 is, that's acceptable for an answer. So if you want to go -0.7, that's entirely acceptable. That wouldn't be a problem. Okay, number 4. So we got a fraction. Fractions are your friends. Guess you're not buying that. So I got a 3/5 n. Now, there's more than one way to get rid of the 3/5. I'm going to show you the long way because I just think it's easier to remember. If you worry about one thing at a time, fraction bar means divide. So if you think about it, that's literally saying 3 divided by 5. How do I get rid of a divide by 5? I do the opposite. Just remember to do it on both sides. Well, that's going to get rid of the 5s, and granted, I'm still stuck with the 3, but we'll get to him. So how to get rid of the 3? Divide by 3. And it's -5. So as you can see, my handwriting is going downhill, but I'll do my best. So let's take care of 5 and 6 here, and then we're probably going to go part 2 video. So a lot going on in this first problem, or this number 5 problem. But again, a little distributed property here is going to give me a 12x. A little distributed property here is going to give me an 18. All right, now this next part drives me insane. People get this wrong all the time. I am subtracting some stuff. Usually everybody gets this right. Yeah, I know I'm going to subtract a 1. But if you think about it, guys, there's understood to be a 1 right here. If you had a number there, you would not even think twice about doing the distributive property. So, hey, -1 times 1 is -1. Like I said, everybody gets that right. What would happen if you take the -1 times the +12? That would switch the sign. So again, you are subtracting both those guys. So I hope it makes sense that you will be subtracting or switching both signs. And it happens every time when you got a subtract sign in front of a set of parentheses. All right, clean some stuff up. So this is all step 1 simplifying. I see a 12x and I see a -12x. Well, those are going to cancel. I got an 18 and a -1. I better put those together, and I got 17. So this throws some people. The idea is to get the x by itself and solve for x, but the x is gone. So what do you write for an answer? X equals 11, x equals 17? Well, it doesn't say that. So if this ever happens and the x goes away, you're basically stuck with one of 2 possibilities. It's either no solution or all real numbers. And here's how you tell. Is the statement at the end true or false? If it's true, you write all real numbers. But this is definitely not true. 11 does not equal 17. So we're going to write no solution. And that's the symbol for that. All right, I'm going to work this last one in real quick. This looks tough, but it's actually easier, believe it or not, than some of them. I'm going to put this guy over 1. And the reason for it is if I do common denominators for all of them, I'm going to show you what happens. So I can take the 3 and I can multiply it by 4. I just have to multiply the top by 4 to make it match the last denominator. I can go times 2 on the second guy, and I'll have something over 12, 2 over 12. I can go times 12 on this guy and get a 24. And that last one I won't even have to mess with because he's already over 12. Well, guys, how do you get rid of it? Divided by 12. You multiply by 12. And if I multiply one part by 12, I got to multiply everything by 12, which would make all the 12s cancel. So really convenient. Once you get common denominators, you basically get to ignore them. So that leaves me an 8y. That leaves me a 2. That leaves me a 24 and a -y. So I'm about to run out of time here, but I'm just going to keep yakking on this problem until I get cut off. So I got about 15 seconds. But I would just hope that you'd be able to finish it from here. So move the y's. and take it from there. All right, check out part 2.